In section 9.5, we move on to adding and subtracting fractions, rational functions, which are a little more difficult than the multiplying and dividing because we have to create common denominators. So let's go through that. If you're fortunate, you'll start with a problem that already has common denominators. Nothing new to do there. I add the numerators. So 7 plus 11 over 6x is going to be 18 over 6x. 6 goes into 18 three times, and this simplifies to be 3 over x. In this problem, I want to factor my denominators. This difference of two squares, x plus 3 times x minus 3. Factor of this is x minus 3. Now normally I'm going to take the largest denominator in terms of numbers of factors. That's this one. And then I'm going to look at the other denominators, and I can eliminate any duplication. So I've already used x minus 3. That means I don't have to use x minus 3 here. That means that this is the LCD. Okay, that's great because on this fraction I don't have to do anything. I already have the right denominator. This is going to be 6x plus 1 over x plus 3 times x minus 3. And it's going to be plus 4 over x minus 3 times another fraction that equals 1. And that fraction needs to introduce this missing portion of the denominator into here. So it's going to be x plus 3 over x plus 3. Okay, 4 times x plus 3 is 4x plus 12. Over here I have 6x plus 1. And that's all over my common denominator, x plus 3 times x minus 3. 6x plus 4x is 10x. 1 plus 12 is 13. All over x plus 3 times x minus 3. Now, I would also at this point want to look to see if I could factor the numerator and cancel common factors. So in this case, simplification happens at the end. In the case of multiplying and division, simplification happens first. But there's always simplification involved in these problems. If you take a look at this problem, I want to factor the denominators. This is going to be x plus 4 times x plus 4. This one is the difference of two squares, so it's x plus 4 times x minus 4. And I'm going to take this item. I've got a repeated factor, but it happens in one single denominator, so I do have to use it both times. When I look at this one, I've got an x plus 4, but I've already used x plus 4 twice. I don't have to use it here. But then I have x plus 4. This is a new factor. I'm going to have to use that. So my denominator is going to be x plus 4 times x plus 4 times x minus 4. And I'm writing it down here because that's what we need to create. Now I'm going to multiply each of these fractions by fractions that equals 1 to create this common denominator. So I'm going to take 2x plus 1 over x plus 4 times x plus 4. And the factor I'm missing here is the x minus 4. So I need to multiply the denominator by x minus 4, and therefore that's what I multiply the numerator by. Minus this fraction, 3 over x plus 4 times x minus 4. And what's missing in this denominator is the second x plus 4, so I need to multiply that denominator by x plus 4, and therefore that's what I multiply the numerator by. Okay, so when I do this multiplication, I'm going to go ahead and bring those down here on the numerator of this fraction. 2x plus 1 times x minus 4. 2x times x is 2x squared. 2x times minus 4 is minus 8x. Plus 1x, that's minus 7x. And 1 times negative 4 is minus 4. And over here, 3 times x plus 4 is going to be 3x plus 12. And when I simplify this, I'm going to rewrite this as x plus 4 squared times x minus 4 2x minus, 2x squared minus no other x squared, so it's going to be 2x squared. Minus 7x minus 3x is minus 10x. Minus 4 times 12, minus 4 minus 12 is minus 16. And this is my final solution. Now I would still want to try to factor this. I know I could factor a 2 out of this. This is 2 times x squared minus 5x minus 8. And then I'd want to see if I could factor this quadratic equation, factors of 8 that have a difference of 5. This is non-factorable. So this is a fully simplified solution. I didn't find any common factors to simplify. Another wrinkle in 9.5 is we introduced the concept of complex fractions. And as intimidating as these look, complex fractions are nothing to be really frightened of. They just involve an addition or subtraction problem. In this case, they're both subtraction problems, followed by a division problem. So you just need to do them in 2 steps. So first, I'm going to simplify this denominator. And I'm going to do that by creating common denominators. My common denominator is going to be 4 times x plus 1. That's really easy. So I'm going to have 1/4 times x plus 1 over x plus 1 minus 7 over x plus 1 times 4 over 4. This will create my common denominators. My denominator is going to be 4 times x plus 1. And here I'm going to get x plus 1 minus 28. And this simplifies to be x minus 27 over 4 times x plus 1. Great. Now this is the fraction that's going to go here in the denominator of my complex fraction. And when I go through this, this was the first step. Now let's go on to the second step. I'm going to have 20 over x plus 1 divided by x minus 27 over 4 times x plus 1. Okay, when I invert and multiply, I'm going to bring this down over here. I have 20 over x plus 1 times 4 times x plus 1 over x minus 27. I inverted this fraction. I'm going to cancel common factors. And then I'm going to multiply, and I get 80 over x minus 27. Okay, very relatively simple. All that really happens with these fractions is complex fractions is that you have an addition or subtraction problem to do first, and then you do the division. Okay, so if we work on this, I'm going to start off with this denominator. Let's separate here. So this is 1 over x squared minus 2 over, I'm going to factor this, x squared times x plus 1. So you can see x squared times x plus 1 is my common denominator. I just have to introduce the x plus 1 to this portion of the fraction. So I multiply it times x plus 1 over x plus 1 minus 2 over x squared times x plus 1. And when I do this, I'm going to get x plus 1 minus 2. That's going to end up being x minus 1. Okay, and I'm going to go ahead and put that over here. X minus 1 over x squared times x plus 1. Now if I bring this guy down, and I'll write it horizontally this time because maybe that's a little simpler for people, x to the 4th divided by. That means I can invert this and multiply. Right, so I'll have 1 minus x over x to the 4th times x squared times x plus 1 over x minus 1. Now, I can factor a negative 1 out of this. This is going to be the opposite of x minus 1. This cancels with that. X squared cancels with x to the 4th and leaves x squared. So I end up with the opposite of x plus 1 all over x squared. Sorry, the space was a little tight on this slide, but you get the point.